the big question, and in my 5.5 years here, I find that every time you find something, you have 20 more questions, and I'm sure most people feel the same way, is what's going on then? And so here's kind of how we typically think of AHUS. Here's the alternative pathway. Here's all of our regulators. And the genes in blue are genes we know are involved, and red are the genes that kind of have been implicated because of this study. And you get no regulation, you get cell lysis, and you get disease. And then working in parallel is this whole other pathway, the coagulation pathway. And all of these genes not only can interact with the alternative pathway, but they have their own purpose. And their own purpose is actually to degrade blood clots and get these fibrin degradation products. Well, we know when these genes are not able to do their job, what you get is thrombosis. And that should sound familiar to everybody. And what we're thinking is we know that these genes are important in like TTP, but it's possible also that they're a modifier in AHUS. So maybe you get a mutation in factor I, so your dysregulation is not very good, but you're already set up that you're kind of predisposed to getting thrombosis already, and so you get that second hit. So there's more going on than we might have originally thought. And so in summary, we think that sequence capture technology is uniquely suited to diseases like AHUS because they're complex. You're usually not going to get one mutation that explains everything. And it's important to provide kind of what we call a complement profile for patients, just so you can understand more what's the progress of disease and what the best treatments are. And then it's also aided in the identification of possible novel genes such as ADAMTS13 and the related. And it's actually implicated a whole nother pathway, the coagulation pathway, that maybe we hadn't been looking at but maybe could be important in answering some of those other questions. So what does this all mean? So we believe the related genes are important. And it's possible that ADAMTS13 can act as that second hit. And this may explain, again, the low penetrance of known mutations. Why does my family member not have AHUS if they have the same mutation as my other child? Or why does the same mutation lead to different diseases that are both complement regulated? But there's still a lot that needs to be done. We need to have further proof that variants are functional before we start saying anything to physicians. And we're working with collaborators to show that a few of the other ADAMTS13 variants are functional. And we need serum for this. And this is why when we ask for DNA, if you fill out the consent form, why we ask for serum, so that if we find something, we can test it. And then we're also in the process of cloning mutant forms of related to, for example, to test if they affect the regulation of the complement cascade, specifically the alternative pathway, but it also could regulate the MAP, so maybe the whole complement cascade. And then we're also in the process of screening, going back to other patients that haven't been screened for ADAMTS13 and screening them and seeing if there's anything that we can find to help answer questions that a year ago we couldn't answer. And I just want to thank everybody in the lab. Richard and Carla helped me a lot, because when we first found all those mutations in ADAMTS13, I went to Richard and I'm like, I think half our patients have TTP. I think something's going on. But she talked me through it and explained how difficult it is to tell the difference between the two, and that maybe we were finding something new. So that was very helpful. And of course, I want to thank all of you for being here and taking the time out of your schedules to come and listen to us talk about what we've done, and who've given blood so that we can do these kind of studies and not only hopefully help your families, but help other families to understand what's going on. And obviously I want to thank the Foundation for Children, because they've helped fund me for all of these years. And so thank you. And if you have questions, just let me know.
I have a little trouble getting my head around the implications of what you all said, because we always try to keep it simple. So we got calls from people with TTP. We said, oh, that's neurological or kidney. It's similar. But are you saying that there's like so are you trying to say that there could be an overlap? So those of us with some kidney failure could see, because it seems like we have a larger percentage of neurological issues in the room, just talking, from people, than the general population. So is that the link you're saying, or is it still different than that?
Okay, so that's great because you actually brought up something that I forgot. So I'm not an MD or clinician, so I still think of them as two separate diseases that are hard to tell the difference between, but I think that's up for debate amongst some clinicians. But what I will say is that we tend to find that in aHUS patients, if they have a variant ADAMTS13, they have one working copy and one non-working copy. In patients with TTT, they have no working copies. So it seems like it's involved in different ways. So it might be you get a bigger hit without any ADAMTS13 and you get TTP, and if you have at least half of your protein is working correctly, it's enough to contribute to an aHUS phenotype.
So that 44% of the people, if we looked at them, we might find that this is the solution to some of those.
We would find that this might help explain some of those cases. I think we'd find a lot more mutations in the terminal complex, so C9, C8, those genes, as well as regulators of those genes, especially. And I think we're also going to find more mutations in related to and related for